Good morning. So in this lecture video, I'm going to explain how do we interface LED and switch to a port pin, and then the set of LEDs and the set of switches into a wall port. So let's see interfacing a simple switch and LED to I/O port pin. So we have a different types of switches, So we'll consider a simple push button switch. So, so that we have to interface to 8051 microcontroller. Consider 8051 microcontroller, and let's say we interface a switch into port pin P2.0. So this is the simple switch, open and close switch, open and close switch. See, when it is closed, when it is closed, 0 is supplied to the pin. 0 is supplied to the pin P2.0. We can say the switch is closed. So when it is open, it floats into high impedance state. High impedance state. So to overcome this high impedance state, we connect one resistor. We connect to VCC through a 1 kilo resistor. That means when it is open, it gets value 1. That means VCC. If it is closed, it is a 0. That means when a switch is open, P2.0 is 1. When it is closed, P2.0 is a 0. Clear na? So, and this must be configured as an input pin because we are reading the status of the switch. So microcontroller reads the value. So it should be configured as an input pin. And that means we need to write one to the corresponding latch as I explained in the operation of ports. And we'll consider one LED, simple light emitting diode. So that will interface to P1.0. That means through resistor we connect anode terminal to P1.0 and cathode terminal is connected to ground. This is a simple connection of LED interfacing to the pin 1.0. And here LED is on LED is on when this pin drives 1. That means provides plus 5 volt. Then there is a potential difference between the anode and cathode. Then current will flow. So then LED makes on. So when this pin drives 0, okay, when pin 0 means provides 0 volt, there is no potential difference between the anode and cathode. Hence current will not flow through it and makes LED off. So that means P1.0 must be configured as the output pin. So microcontroller is giving the value. So it should be configured as an output pin. That means we should write 0 to the corresponding latch. So this is a simple connection. That means we'll write a program ALP to switch on or off LED based on the status of switch. Let's say when the switch is on, LED on, and the switch is off, LED off. So as we know, switch is off when P2.0 is 1 and switch is on means we receive P2.0 as a 0. So that means to make LED on, we should make P1.0 1. To make LED off, P1.0 is equal to 0. So that means to say whenever P2.0 is 1, we should write P1.0 0. If it is 0, we should write 1 to the P1.0. So with this, and we should make P2.0 input pin, that means we should write 1, and we should make P1.0 output pin, that means we should write 0. So with this idea, we'll write a program. Start with 0, set bit P2.0, that means we write 1 to the P2.0, it becomes input pin. Similarly, clear P1.0, that means we write 0 to the P1.0, so it becomes output pin. Okay. And then read the switch status. So that means move C P2.0, that means content of the pin P2.0 is copied to carry flag. Okay, and then complement it, because so when it is 1, we should write 0 to the P1.0. When it is 0, we should write 1 to the P1.0. So complement it, and then write into P1.0. So move P1.0 comma C, write the LED. Okay, So if you want to continuous read, jump to move C comma P2 dot 0. Read complement and write into LT. Read the switch complement and write into LT. It is keep on continuing. Okay. End with the control loop. This is the program to read the switch and make LED on or off based on the status of a switch. And see, so we can connect another way. See here, whenever the one end of the switch is connected to port pin, other end is connected to VCC. Other end is connected to VCC. That means whenever it is closed, it creates 1. Whenever it is open, again it is in high impedance state. So to overcome that, we connect resistor. Uh, we connect ground through the resistor. So whenever it is open, it reads 0. Whenever it is closed, it reads 1. This is another way of connecting the switch. So in the previous, one end of the switch is connected to port pin, other end is connected to ground. Here other end is connected to VCC. To overcome the float stage, high impedance state, we connect to a ground through resistor. So in this case, switch is open means off, that is P2 dot 0 is 0. So 0 means open, 1 means close. Okay, na? So again same configuration, LED is on. Okay. It is off when P1 dot 0 is equal to 0. So that means in this interfacing diagram, we should make P1 dot 0 1 when P2 dot 0 is 1. Same thing. Okay. If it is 0, so make LEDs is 0. So this is the program. So in the previous case, we complemented, no? We complemented, no? That we remove. That's all. That we remove directly. Read the switch and copy into the LED. Read the switch, copy into LED. This is the small changes in the program. So you must understand the hardware before writing the program. You must understand the hardware, how the hardware is designed. Then only we can write a program. That means what is the value the ports are reading. Now see this diagram. So some set of LEDs are connected. Some set of LEDs are connected to the port 0. You can change the port. You can change the port based on the application. This is how the connection. This is the connection. So array of LEDs are connected like this. Anode terminals are connected to port pin and all cathode terminals are shorted and connected to ground. And see this diagram, set of switches are connected to port 2. So as I said, you can change the port. Okay. So one end of the switch is connected to port pin, other end all shorted and connected to ground. To overcome the high impedance state, we connected VCC. That means when the switch is open, the value is 1. When the switch is closed, the value is 0. So let's see the program. This is for an individual pin. This is for individual pin. For port, the changes is, see, move P2 comma H0FFH means here we made only one pin 1. Here we need to make whole port now, so copy 8 ones, that is FFH to port 2. So port 2 P2 becomes input port, and then P0 becomes output port. So this is P0. Okay. And then same read, okay, complement. So read, so here we use move C comma P2 dot 0 because only one bit. So here we need to 8 bit now. So move A comma whole port P2. Read the status of switches, complement it. Here we use complement C, here we use complement A. Then copy into port 0. That's all. Okay, our thing is same. Only the changes is here we do individual bit, here we use whole port. This is the changes in the program. So as I said, we can connect like this also. In the previous, other one end is connected to port pin, other end is connected to ground. Here we can connect other end to VCC. In this case, this is the changes in the program. So here we use complement, no? Here we use complement. So here is as per this diagram, complement is not required. Complement is not required. So just remove the complement. Just remove the complement. So this is the program for single pin. This is the program for whole port. Okay, this is how we interface LED, either single LED and a single switch, or a set of LEDs and set of switches into a whole port. Okay, so thank you.